Hello, this is a video on the last part of non-right angle triangles, which is to find the area of a non-right angle triangle. Okay, so in primary school and year 7 you would have learned that to find the area of a triangle you do half base times height, or base times height divided by 2, which is fine if you've got the base and the height, and the base and the height are perpendicular to each other. In other words, there's a right angle in there somewhere. Well, we know that in this topic there are no right angles, so you can't use half base times height for non-right angle triangles. Okay. Instead, we have a separate formula which is similar. It's still got a half in it, but it's a half AB sine C. Okay. And if you look at the triangle there, A and B are two sides, and C is the angle in between them. So very similar to what you used for the cosine rule, actually, where you have two sides and an angle in between. Okay, but this time we're going to call the two sides A and B and the angle capital C. So when you have questions on this, you can just relabel the corners of the triangle to match. Alright, so whereas before, when it was the cosine rule, we called the angle capital A. When we're doing area, we call it capital C. I've no idea why, but that's the form it's given to you on the front of the exam, so we may as well use it. Okay. So get that down in your books, and I'm going to do a couple of different types of questions with you, and then you're going to have a go at some yourself. Okay, look at this top question then. Do we have two sides and the angle in between? Well, we've got our two sides, so that'll be A and B. And yes, we do have the angle in between, that'll be C. So all we've got to do for this first one, area equals a half, and on your calculator you could even use 0.5. So a half times 6 times 7 times sine of 60, and that triangle has got an area of 18.19. And as usual, we're measuring in centimetres, so the units are centimetres squared. There's no difference there. So really simple, as long as you've got two sides and an angle in between. Okay. Have a look at this next one. So draw it, have a look at it, and see if you can tell what's different before I give it away. Move this down a bit. This time we've got two sides, but we don't have the included angle. So we're going to need to figure out the size of this angle here before we can find the area. So how can we do that? Well, I've got a pair, okay, and anytime you've got a pair, that should tell you that we're going to be using the sine rule. Okay, so get used to mixing and matching the work you've done in the last week on these triangle questions. So we're going to use the sine rule. Now the other pair we've got here is with the 20. So what we're going to have to do is find angle B first, and then we'll use A and B to find C. So a bit of a potch this one, but we'll get there. Okay, so let's make our fractions for the sine rule. So we've got sine 60 over 18, because they're a pair, equals sine B over 20, because they are a pair. We move the 20 up and over, and so into your calculators, if you type 20 times sine 60 over 18, that'll give us sine B. Okay, and if you type that in, you should get 0.962 ... Remembering back then, if you want to find B, you have to do the inverse operation of sine, which is sine minus 1. So sine minus 1, you can use the answer key as well if you've left the number on the screen. And angle B comes out as 74.2 degrees. So that goes up there. Which still doesn't help us to find the area because it's not the included angle. But if we use the 180 degree rule, angles in a triangle add up to 180. We should get that angle C is 45.8 degrees, and that's the important one because that's our included angle, 45.8 degrees. And now it's straightforward, so just put those numbers, let me sort of ruler this off, into the formula. So a half times 20 times 18 times sine of 45.8, squeeze it on there, yeah, and you get an area of 129.04, and again centimetres squared. So a bit of mucking around on that one, but a question like that in an exam would be worth about 6 marks. So you do get well rewarded if you have to do lots of steps. Okay. Next one. This is a backwards one. I've given you the area and I'm missing a side. Okay, but it's still two sides and included angle, so it's fine. So we'll have A there, B there, capital C. Our formula, remember, is that a half AB sine C equals the area. So that means a half times 9 times x, which we don't know, times sine 64 equals 30. We've done a lot of maths like this recently, rearranging to find a missing side or a missing angle. We need to divide by sine 64. Okay, make sure you leave your numbers on the screen as you're doing this. So divide by sine 64, so 30 divided by sine 64, press equals. We also need to divide by 9, press equals. We also need to divide by a half, or 0.5, however you want to type it in. Okay, one of the two. And what you should get then is that x, because x is the only thing left on the left hand side, is 7.42 centimetres. So a simple bit of rearranging, because we knew the area was 30. So bring things over and divide, and what you're left with is x. So that's straightforward enough. This is similar. Again, I've given you the area, but it's the angle that we're missing. So if we write out the formula with what we know, a half times 13 times 19 times sine theta is equal to 50 this time. The area is 50. And if we divide by the things we can divide by, so 50 divided by 19, press equals, leave it on the screen. Divide by 13, press equals, leave it on the screen. And divide by a half. Again, press equals, leave it on the screen. What you'll be left with is sine theta on the left, because everything else has gone. 0.404 hopefully is what you've got on your calculator screen. And that is sine theta. So just like we did earlier on when we were using the sine rule, to work out theta, we do sine minus 1 of 0.404. Remember, you can use the answer key on your calculator, and I get an angle of 23.88 degrees. And that is pretty much all you can do with the area formula. You can use it forwards if you've got two sides and the included angle. You can use it backwards to find a side, or you can use it backwards to find an angle. Okay, so most of the questions I'm going to set you are going to follow one of those styles. But this is where now we start mixing and matching topics, because this is A grade work, A-star work. You're going to expect to see various topics mixed together. So have a look at this one, and again, this needs to go in your book. This is mixing triangles with sectors. Okay, and in this question, what we're going to try and do is work out the shaded area. So get this drawn, pause the video if you need to. We're going to work out the shaded area. And hopefully you can see that what's happened there is we've got a sector, which you should know your formulas for, looking like that. We've got a triangle, which shares a lot of the same numbers, shares the same angle, shares the same length of sides. But what I'm interested in, this red bit at the top, is the difference. So the way we do the maths here is we find the area of the sector, we take away the area of the triangle, and what we should be left with is that little bit at the top. Okay? So to find the area of a sector, you need to know the angle, you need to know the radius. So the angle is 38, the radius is 12. So 38 over 360, its area, so pi r squared, times pi times 12 squared. The sector, if we wanted all of it, has got an area of 47.75. Then we look at the triangle on its own. So 12, 12, 38. So this time that's our A, B and capital C. So a half times 12 times 12 times sine 38. The triangle on its own, ignoring the little bit at the top, has got an area of 44.33. This is all in centimetres squared, remember? So why has the sector got a bigger area than the triangle? It's because of the shaded red bit on the top. So all you've got to do to find the shaded area now is take those two numbers away from each other. So 47.75, take away 44.33, the shaded area is 3.42 centimetres squared. Okay, so that's a little tricky question there, mixing up arcs and sectors work from before Christmas with triangles work that we're doing this week. I'll attach a worksheet for you to have a go at, just practicing using the formula forwards, backwards, and I'll put a few of those mixed arcs and sectors ones on there as well for you to have a little go at.